Okay guys, this is my second shot at making a video for you in hopes that the material is going to make a little bit more sense the way I explain it. I've got some feedback from some of you that said that you need to make a video. So I'm going to give it a shot and I want to hear from you guys and what you think. Today, I'm going to go over notes 9.4. So I'm going to be using a lot of the examples from your notes so you can have a good idea of what your notes should be looking like if you did not look at the key that's on Google Classroom. Okay, so first of all, slope-intercept form is just a different way to write an equation using some information that you know. Now, the one thing I want to clear up is like, what in the heck does a line represent? Well, we can write an equation that represents the line, and that's kind of where slope-intercept form comes into play. That equation can be used to find all possible points on that line, which we'll be doing in the next lesson. Okay, so first let's just focus on that equation, slope-intercept form. So here we have y equals mx plus b. Okay, now the x and the y are pretty straightforward. Okay, that would be your x coordinate, and this would be your y coordinate, kind of like duh. The M and the B is what gets a little bit tricky, and if you want to write this down to use it on a quiz, that's cool. Eventually, I think it'll just stick in your head, but if not, well, you have this. So, M, that's my dog. M is your slope. Remember, your slope is your rise over run. Last week, we found our slope using y2 minus y1 over x2 minus x1 with two coordinates. Okay. Now, slope, now that b, the b is your y-intercept. Your y-intercept is where that line crosses the y-axis. So if I have a line here, okay, I'm just making this up. If I had like an actual graph when I could count, and I could estimate this by just spacing it out in my head, but the things to know is your y-intercept. That's something you can always plug in. So here is my y-axis. This point right here is your y-intercept. And what I would do is I would just take whatever spot that line is on the y, I would plug it in to that b. So let's say this is 2. So if that's the only thing I knew, I could write y equals mx plus 2. Whoops, that's not a 2. 2. Let me do that over. Y equals mx plus 2. Now, if I find 2 points on this line, which I very easily could, there's another point, I could find my slope. Watch this. So, here is my one point, here's my other point, so I'm just going to find the coordinates. Let's say 1, 2, 3. So one coordinate would be 3, 0. the second coordinate would be 0, 2. And there's my 2 points that I can plug into this formula to find my slope. So here, x1, y1, x2, y2, and I plug it into here. So if I look up there, y2 minus y1, 2 minus 0, x2 minus x1, 0 minus 3. Can you see that? Yeah, you can see that. Okay. 2 minus 0 is 2. 0 minus 3 is negative 3. So my slope would be negative 2 over 3, or 2 over negative 3. That's called a negative slope. I have a negative slope right here. I know I went through that part really fast, but that's not the goal of this target. That was just a quick little review. The goal is, in order to graph a line from an equation, we have to have things written in slope-intercept form. So that's the only goal of this lesson, is to write things in slope-intercept form. Okay, first page of your blue notes have an example of y equals 2x plus 3. Now, something that I always do, even now, is I write the formula for slope-intercept form, or the form of it, of that equation, at the top of my paper every single time. Okay. If the equation does not look like this, when we're talking about graphing points and slope-intercept form and y-intercept, we have to make it look like that. Okay? So if it doesn't look like that, we have to solve for y. So we have to move everything around. So in example 1 in the video, you had the problem y equals 2x plus 3. Does that fit slope-intercept form? Well, let's take a look. That's Bear crying. Y, yep, equals. Y always is going to be by itself if we're on the right track. 2x plus 3. That's written in slope-intercept form. So my slope is 2, or 2 over 1. My y-intercept is 3. So I could graph my line based on the information I have right here. I'm gonna write right below, I'm gonna write right next to it. So here's my graph. It's not fancy, but I do know where my line crosses the y-axis. It crosses a line at 3. 1, 2, 3. Remember, I'm just making those up. I do know my slope is 2 over 1. So I rise 2, I go up 2, and I go right 1. So to graph another point so I can make my line, I just count up 1, 2, and over 1. Can I make a line? Yes, I can. Now, I don't have, yes, I do. I have a straight edge. Hang tight. Look, puppy. So I have those 2 dots. I connect them. I draw my straight line. Bam. Just with those 2 numbers, I can, if it's written in slope-intercept form, I can graph a line. But again, that's a little extra. Okay, flipping over. So that first one, we were good. Now the second one, I had negative 2x plus y equals 3. Y equals mx plus b. Is y by itself? Nope. So I have to get y by itself. So the very first thing I have to do is move negative 2x. How do I move negative 2x? Someone's going to call out, I add 2x to each side. Okay, I'll do that. Remember, that always cancels out. Now I'm left with y on that left, so I'm in really good shape. Now, be careful. I can't just write 3 plus 2x. I have to write it in slope-intercept form. So I know I have 3. That's my y-intercept. 2x. The number that's next to the x goes first. So I rewrite as 2x. That's a positive 3 plus 3. Bam, you're done. You just wrote that in slope-intercept form. Okie dokie. Okay, let's go down to y minus 5. Equals 2x minus 1. Don't let more numbers fool you. We are still getting y by itself. So here, y is not by itself, so I have to move that minus 5. To move that minus 5, I have to add 5 to each side. Add 5 here, add 5 here. That cancels out. So now I'm in good shape again. I have y by itself. 2x. Oh, well, look at that. mx, 2x. I can just rewrite that 2x right now. And then negative 1 plus 5 should give me positive 4. I have my slope of 2, or 2 over 1. I have my y-intercept of 4. I could graph a line right now. I'm going to do that just to show you. I'm going to draw a teeny tiny graph this time. Okay. So y-intercept, I always have to use my y-intercept first, is positive 4. So 1, 2, 3, 4. Remember, I'm just estimating. If you had graph paper, you could count the little squares, but we don't, so we're just estimating. So there's my y-intercept. My slope is 2, or 2 over 1. Let me extend that a little bit. So I go up 2, to the right 1, up 2, right 1. Bam, there's my other line. Back to the puppy. I draw my straight line. And there's your line. This will get you ahead for the next lesson. Okay, are we cool with that? So that's the first page. Now, if we take a look at the second page, it's just a little bit different. So on that second page, you have a graph, and you just have to read it to find the y-intercept and count or use that formula y2 minus y1 to find the slope. I personally, if you have the graph of the lines, I would just count. I think it's quicker for these. Y equals mx plus b. Remember, I'm always writing that up top. So in that first problem, I'm going to put the blue notes in front of me right now. So in this first problem, how I did it was I identified the y-intercepts, and I circled it. And then I counted. I had to go down 1, so I knew my y-intercept was negative 1. Now, this should be not, well, this makes my y-intercept b. What we should have done is found our slope. Okay, so the y-intercept and the b are the exact same thing. Okay, So if my y-intercept is -1, then my b value is -1. If my y-intercept is 4, my b value is 4. So this was a little bit tricky. Don't let it trick you. If you have in your head that b is my y-intercept, you're thinking that's the same darn thing. Okay? And that's all this part was. So, now in this part of the worksheet or the notes, they're giving you the slope and they're giving you the y-intercept, and what you have to do is put that information into slope-intercept form. So let's go ahead and do a couple of those examples. Okay, in that first example, we had m equals 2 and b equals -1. I need to write it in y equals mx plus b format. And I know I've told you guys this a lot. Write the original formula first. Sorry, guys. Someone's walking past my house. That's what big dogs sound like. Okay, so I just plug in what I know. I know my m, or my slope. I know my y-intercept, which is the b. So I just rewrite it with those numbers in there. So it would look like this. Y equals 2x. Now, here is a little bit tricky. You can write plus -1. Math. You're interrupting class. Or you can just write -1. I like writing -1. It does not matter if you write it y equals 2x plus -1. You just got to make sure that -1 is inside parentheses. Are you done, Mac? He's not done. Just like our classes, huh? Okay. So I want to do, let's see. Okay, let's look at number 3 on the blue notes. Number 3 on the blue notes is m equals -3/2. So that's my slope. Y. Now, this is tricky. Not really, but kind of. They gave you the coordinates of your y-intercept. Now, your y-intercept, where it crosses the y. So which one is the y? The 0 or the 4? Well, have to remember from first 9.1, x, y. There's my y-intercept. So then I go ahead, write slope-intercept form, y equals mx plus b, and I plug the stuff in. My slope is -3/2. My y-intercept is 4. So it would look then like this. Y equals -3/2x plus 4. Ta-da. Now, that looks a lot different than what we've been doing. We've had whole numbers before. Slope is rise over run, so there's going to be a lot of times where you do see fractions, because remember, we have to travel when our slope tells us the steepness of a line. So down 3, right 2. I was telling a student that I was working with last week that slope, you see slope all over the place. The Americans with Disabilities Act, for example, has a law that says the slope of a wheelchair ramp can only be at a certain measurement. And I honestly don't know what that measurement is, but we're talking for every rise in distance, there has to be a certain amount of run or length. So they can't go up too fast and travel too short, or else you have a really steep ramp and wheelchairs can't get up those ramps, or it's very, very difficult. Think about your stairs. Stairs can be really, really steep to go up, or really, really easy or kind of shallow. Stairs in my old house, really, really steep. They call it a pitch. Okay. So just remember, whenever you see something going uphill or going downhill, you're talking about slopes. How high do you travel versus how long do you travel? Rise over run. Okay, I kind of rambled through that, so my apologies. I'm not going to go over any other examples on this side because I don't want to take up too much of your time, but if there are some numbers that you're having trouble with, holler at me and we'll do a Google Meet, okay? And let me take a look at the last page. Okay, again, these are same idea. We're getting y by itself. Some of them are just a little bit more complicated. So let me go over the two problems that I think are probably the toughest. I'm thinking number 5, and I'm thinking number 6. Okay, let's go over 5 and 6. And then I'll be done because I know I'm at about over 20 minutes and I don't want to be over 30 minutes. Okay, so number 5 says, y equals mx plus b. And then number 5 says negative 6x plus 4y equals 6. Y always has to be by itself. So, rules of isolating variables. Talked about this when we were actually in school. We undo addition or subtraction first. Second, we undo multiplication and division last. So in this particular problem, I have to move negative 6x. I'm moving that whole entire term over to the other side. So that's my undoing addition or subtraction. This is negative 6. So what do you think I have to do? Add or subtract. What's the opposite of negative? Positive, yep. So I have to add 6x to each side. That will cancel out. So I'm left with 4y on the left equals, oh, look at that, 6x, mx, get it? 6x plus 6. But is y by itself? Nope. I have to do what to get y by itself? I'm not moving the whole term, I'm just moving that coefficient. Yep, that's 4. So here I have to divide each side by 4. And this is where we're going to be dealing with some fractions, okay? It's okay if you have fractions in any part of this. That will cancel out. Now, the way I like to do this is I would not use your calculator for this. I would just write these fractions straight out so you can kind of take a look at them. Because rise over run, you can leave as a fraction. And you can actually leave your y-intercept as a fraction, but we do have to reduce those to lowest terms. So if I do this, I have to divide each term by 4. So let's start off by just writing those fractions without reducing. So here I have 6x over 4 plus 6 divided by 4, or 6 over 4. Ooh, look, they're both even numbers. How easy will that be to divide by what number? Even 2. So my next line would look like this. 6x divided by 2 would be 3. Well, remember the x goes on the side. 4 divided by 2 is 2. So I have 3 over 2x. Remember, because I'm keeping it in that mx form. I'll let that sink in for about 5 seconds. Okay, throw my plus sign in, and then here I just reduce this fraction. 6 divided by 4. 6 divided by 2, 4 divided by 2. I have 3 over 2, but wait, that's an improper fraction. Is that cool? Do we leave improper fractions improper? Yes. We are not graphing this. If we were graphing this, it might be wise to change that to a decimal because it would be easier to graph on a whole number, but we don't need to do that right now, so just let that be. If you wanted to convert it to a decimal, 3 divided by 2 is, I have to do that on paper, 1, 0, bring down the 0, 1.5. So you wouldn't be exactly on a line. But for all intents and purposes, let's leave it be. If we were graphing, it'd be a different story. Okay, you guys cool on 5? I'm almost out of time. I'm hitting almost 30 minutes. So I'm going to try to take this a little bit, not quicker, but just try to be more efficient. Y equals mx plus b. So number 6, I have 6x minus 9y equals 12. Y is not by itself, so I have to move 6x minus 6x here, minus 6x here. That cancels out. Then I'm left with minus or negative 9y equals 12. Whoops, I lied. Negative 6x plus 12, because I want to keep it in that form. Y is multiplied by a negative 9, so I have to divide each side by a negative 9. That cancels out. Y equals 6 divided by negative 9. So 6 divided by negative 9. X plus 12 divided by negative 9. I can reduce those fractions. I can divide 6 and 9 by 3. So 6 divided by 3 is 2. Negative 9 divided by 3 is negative 3. So I have 2 over negative 3x plus, oh look, I can divide 12 by 3 and 9 by 3. So 12 divided by 3 is 4. Negative 9 divided by 3 is negative 3. Bam, you're done. Okay, if you have questions if you have questions, the very first thing I want you to do is to re-watch parts of this video. Because sometimes you just need it to be explained again for it to sink in. You might have one part, but then you need a repeat of the next step. So that's the joy of having these videos. You can re-watch it. If there are still questions that you do not understand, I want you to jot them down so then when we do a Google Meet, you can have your questions ready to go and I can pinpoint exactly what to work on, okay? So this is today's lesson, Tuesday, April 21st, okay? If you like this better, I would appreciate your feedback, okay guys? Have a great day and we'll talk to you soon, okay? Bye.